Okay, so time to do a couple more examples of predicting redox reactions. Example 2 on the sheet of notes you have says potassium permanganate solution is poured into an acidic iron 2 sulfate solution. So potassium, and it says solution, so it's going to dissociate. Permanganate, so that's the MnO4 negative again, aqueous. Solution, water, is poured into an acidic, H positive, acidic iron 2 sulfate, Fe2 positive, aqueous, sulfate is SO4 2 negative, aqueous, and we already wrote the water down once, so we don't have to write it down again. Okay, so now you're going to go to your chart and you're going to find these. Okay, so when you look, potassium is all the way, positive is all the way down at the bottom. It's an OA, but it's second from the bottom. Permanganate we had already found earlier. It is there linked with the hydrogen atoms, so it's an OA. It's not there by itself, but you could double check and look, but it isn't. If you look for water, you will find it both on the OA side and the RA side. All right, Fe we haven't looked for before, but if you did the practice questions from yesterday, you would remember perhaps that it's both on the OA side and the RA side. And then the SO4 we haven't looked for yet either, but when you do, you will find that it is there linked, I believe. Just have to double check here. So it's second from the top, it's linked with PbO2, but we don't have PbO2, so you cannot use that one. But about halfway down the page at positive 0.17, you will find it linked with H positive. Okay? Just looking to make sure. And at about negative 0.93, you will find it linked with water. Yeah. Okay? So you need to do this one, and it's an OA. And then you need to do this one, and it's an OA. Okay? And that's it for RAs. All right, so now our next step is to figure out which one's the strongest. So which one is the strongest oxidizing agent? Which one is closest to the top? It's this guy. He's third from the top. Which one is the strongest reducing agent? Which one is closest to the bottom on the right-hand side? It's the iron. Okay, so now once you have those, now you're going to copy right from the table the two half reactions. So the MnO4 is exactly what we had up top. So it'll be MnO4 negative aqueous plus 8 hydrogens aqueous plus 5 electrons going to Mn2 positive aqueous plus 4 waters. All right, so that one was easy. We've already used it. You have to be careful with the iron. The iron is the one that's on the 2 positive iron. Remember, it shows up on both sides. But you can't use this one because it's on the oxidizing side. You have to use the one that's on the reducing side. Okay, you have to use the one that's the Fe2 positive going to the Fe3 positive. All right, so Fe2 positive aqueous going to Fe3 positive aqueous plus 1 electron. Okay, now you need to balance your electrons. This one has 5, this one only has 1. Put a square bracket here, put a 5 in front, and now you can add these guys together. So MnO4 negative aqueous plus 8 hydrogens plus 5 iron 2 going to, ooh, I didn't make my going to long enough to write spontaneous or non-spontaneous on it. Mn2 positive aqueous plus 5 iron 3s plus 4 waters. Okay, and then the last step, go to your chart, put one finger on the MnO4, the oxidizing agent, one on the Fe2 positive, the reducing agent. Oxidizing is above reducing. This is spontaneous. So don't get lulled into a false sense, though. They're not going to all be spontaneous just because the first two we did were sample 3. Says, could copper pipe be used to transport HCl solution? Copper pipe, that will be copper solid. HCl, H positive, Cl negative, aqueous solution, H2O. Okay, and so now we need to do our oxidizing and reducing, and I just do these in different colors so that you're easy for you to see. Copper solid, it's going to be on the reducing side. H positive by itself on the oxidizing side. Just to make sure you, right? So copper's here. H positive is, I wanted to say up here somewhere. Honest, it's on this side. I know it's here somewhere. There it is. And water is also on this side. So those are all the oxidizing agents. The reducing agent, Cl negative, is going to be over here. It's there linked with water, and it's there by itself. Okay, so Ra, and we know water is an Ra. So now look to see which one's highest up. It's actually the copper that's the strongest Ra. Whoops, and I already put this in because I knew it was above water. Okay, so now we do our 2 half reactions. And they're nice and short this time. It's 2 H positive aqueous plus 2 electrons going to H2 gas, and Cu solid going to Cu2 positive aqueous plus 2 electrons. Don't have to multiply by anything, add them together. 2H positive aqueous plus Cu solid going to H2 gas plus Cu2 positive aqueous. Now you do the last step. You come over here, you put one finger, okay, it already took me long enough, on your copper solid and one finger on your H positive. The oxidizing is below the reducing. This is non-spontaneous. Non-spontaneous. Now you have to go back to the question, because the question said, could it be used to transport? Could copper pipe be used to transport HCl? Yes, because the reaction is non-spontaneous. The hydrochloric acid is not going to eat away at the copper pipe. Okay, so what you've just proven is that yes, it could be. All right, so now you get to do some on your own.